Imagine that you and another developer are tasked with two parts of the same software. You meet, discuss how these parts may interface, and go off to do work on your own. In all likelihood, this software will be organized just like the people that produced it, two components that communicate in agreed upon ways. Extend this a little bit further. Now there are 5 people, 2 in one group and 3 in the other. In all likelihood, one group will split their problem into 2, and the other will split their problem in 3. Or perhaps a larger group will assign their third person to be concerned with the communication between groups, so that the 2 layers will each have 2 components. That's a situation you see in this diagram. A study at the Harvard Business School by McCormick and others in 2007 showed that looser organizational structures, such as in open source projects, led to more loosely coupled modular code. In-house development teams tended toward tighter coupling. They suggest this difference could be due to conscious choices by the developers, or just a natural consequence of the environment in which the software is developed. These examples illustrate Conway's Law. A system will tend to take a form that is congruous to the organization that produced it. Putting a team together without regard to Conway's Law may lead to unintended consequences for the software architecture. For example, your team may start out with the intention to build a highly modular and loosely coupled software system, but the team did not talk about the interfaces among the components at the time. However, you all work in the same room at the same office. The constant communication makes it too easy to bind the components together with tight coupling, because you did not plan the connections between components in advance. In the end, the code is not as reusable or maintainable as originally intended, because the structures of the work process and work group did not lead naturally to the desired result. On the other hand, knowledge of Conway's Law can be harnessed to plan development teams around the desired architecture. Luckily, many programmers know Conway's Law or intuitively understand it even if they don't know it by name. If you're putting together a team of developers, it helps to first plan the architecture that works best for the system and to organize the team around that architecture. If you're building a web application, for example, your architecture is likely to be N-tier with 3 tiers. You could have a team that builds the data backend, one team that builds the application logic layer, and one team that builds the presentation tier. Having some flexibility could also be useful in cases where implementation of a component is not yet known or may change. Conway's Law implies that extra work may be needed to provide unified and scalable architectures. If you have 5 groups working on 5 subsystems of a software system, the software will probably end up being a set of paired integrations rather than a more extensible architecture. It would be better to split off some people into a new team, whose purpose is to consolidate and enforce common services across the whole system. Conway's Law is widely known and widely applicable in the software world. It will help organize effective teams or identify inefficient ones. Despite its name, it's more of an observation and could be stretched or broken in some cases. Even then, it helps to be aware of it and the implications it holds for putting together your team of developers and your software architecture.